Well, good afternoon. We're really great to have. It's great to have all you all here today. And when I get up here, every time I feel like one of the broadcasters from the Mary Tyler Moore show who never got it right, because I know I'm gonna mess something up, but I'm gonna do my best. The National Center for the Biotechnology Workforce and the Math, Science, and Technology Division have been doing these presentations for about 10 years. And in that 10 years, we've had more than 50 lectures that have taken place. And we're really looking forward to this year. We believe that this year is going to be extra special. And we posted speakers that at least through December. So we're looking forward to it. And we'd like to thank the SciTech Foundation and the North Carolina Biotechnology Center for their support. And Dr. Damaris is going to introduce our speaker.
Thank you. So Ken grew up in Durham, North Carolina, beginning at, I love this, Watts Elementary, and ending up down the road at Davidson College. At Davidson, and as a National Merit Scholar, Ken placed out of every computer science course they had. So we got a degree in biology and neural simulation in 1994. That degree included a semester of fieldwork in statistics, tracking dolphin populations in the Gulf of Baja, Mexico, a little bit of laboratory brain surgery, and a year abroad working in London as a stock market analyst. Eclectic combination. Traveling west, Ken created businesses in Colorado, then California, selling Virtual Alchemy, a serious games video game company, to a North Carolina firm that moved him back home. That group expanded and was bought by Lockheed Martin, where he won Technologist of the Year and built 3D interactive instruction for the military, healthcare, and the power industry. More importantly, and I would add, I really like this part, his mother, Carolee Duckworth, a PhD in instructional technology, filled his head around the dinner table with tales of peer proctoring, mastery learning, and learning management systems from the 1980s onward. That has all fostered in him a lifelong commitment to optimize learning and instruction with technologies like 3D interaction and lately the newest artificial intelligence advances in machine learning. Welcome.
Test check. Good. All right. So yeah, I'm Ken Lane, and we're going to be talking about partnering with machines, and I mean that in the sense of using computer technology to help us get through our life in ways that are a little bit surprisingly different from the ways that we have done coming up through the 80s and 90s. We've had a technology, information science revolution throughout that period of time. Things are likely to accelerate a little bit as these machines get closer to the capability of what people can do. So just kind of give you a sense of where we're going to go when I'm talking about this stuff. I'm going to talk about how machine learning entered my life and my team's life, and I'm going to talk about some of the fun things that machine learning is doing, ways that you're using machine learning right now every day. You guys are all machine learning users and artificial intelligence users. Just to not scare you with the machine learning phrase, it's a kind of artificial intelligence that's a little bit fancier than what we've had under our fingers to push a button on in the past. There's a lovely taxonomy slide where I'll explain how that all fits together. And that's that next section. And then machine learning applied examples of things that I've been working with and have come across out there in the world. And I'm going to try and give you guys a little bit of a guide for how you might look for problems that machine learning could be helpful in the work that you do or the exploration of information that you do, so that machine learning can take just a little bit of the drudgery out of whatever it is that you are trying to find or accomplish, so that you are not raced ahead of by someone else who found this crazy new button on the calculator that is machine learning, really. So this is kind of like the street cred slide. These are some businesses that I've been part of over the years. And here is my CEO, Richard Boyd, with James Cameron from Avatar. They were working together using 3D technology, video game technology, to help visualize the movie set of The Abyss, so that you could figure out which camera shots could be avoided. And that's an example of using simulation technology to simulate the experiences in the real world such that you can make decisions about the real world. And we're going to come across a lot of other examples of that as we go forward. But the whole idea of being able to mirror the world itself in the virtual space and then use computation, massive computation that we have available to us today, is a theme that we're going to come back to. The company 3D Solve bought my company, Virtual Alchemy, and that moved me back to North Carolina, where I'm from, Durham, and that ended up being bought out by Lockheed Martin and ended up in a group called the Virtual World Labs. Virtual World Labs is where we came across, I think I've got, jump ahead, yeah, here we go. That we've got Alex Kipman and Jaron Lanier. That's the guy who came up with the phrase virtual reality, and that's the guy who figured out the pattern light connect system. And it was nifty. They wanted to talk to us because they wanted to see if Lockheed Martin could help out with the optics inside of this device. They were doing fine on the optics. We flipped it around, and they got us very excited because this guy, Alex Kipman, had a terrible, terrible constraint in his life that was the kind of thing that was a deal killer. They said at Microsoft, hey, we're super excited about this piece of tech you want to attach to it, but you can only have 60 meg to fit everything into. That 60 meg was an impossibly small amount of space into which to fit all of the programming, the traditional artificial intelligence, the handcrafted AI for every living room, every coffee table, every dog walking by, of this connected, if you know what this is, that you stand in front of it and move around, it tracks your hands and arms and legs and head motion. And he had to fit this into this incredibly small space. And he'd heard about this crazy tech called neural networks, which is a type of machine learning. And what he discovered was you can find the strangest of shortcuts when you, instead of acting as a programmer who figures out every piece of a problem, instead takes a lot of examples and feeds those examples through a system, a machine learning system. And those examples train the system in a way that ultimately is beyond the human to understand the complexity that was understood by that system, but it still solves the problem. And I'll get more into that in a little bit. And I think, I guess what I'm kind of talking about is my history is with instruction 3D video game technology using artificial intelligence. And when I say AI, I'm talking about handcrafted AI. You know, the monsters chase you, they dodge around the wall, they have a memory, they have a state machine. That's traditional artificial intelligence. Artificial intelligence where you're trying to get something to seem like a person. Machine learning is a different animal entirely. Yes, it could also end up seeming like a person, but the whole point of it is that instead of having the programmer fully understand the problem and then start writing code, you throw examples by the tens of thousands, hundreds of thousands, hundreds of millions at the system and say, all right, now that you've seen these examples, solve it for me forever anytime I give you a new question. So machine learning is, we'll walk down through it, and I'll let you kind of take a look at that. But the idea is that software that learns for itself, that's kind of what I've been talking about here. But you come across this stuff all the time. You've got, you hear about self-driving cars, but you've probably got a phone with Siri or Cortana or Alexa or Google Assistant. You just push a button and something is understanding your voice. Rewind 5 years, it barely could understand your voice. Rewind 7 years, it really couldn't understand your voice. Rewind 8 years, if you had Dragon Naturally Speaking and you trained it for a half an hour, it might understand your voice. the speed at which these problems are being cracked, and the way that every time it's cracked in a new level, there's a completely new combination of algorithms being stitched together in order to crack that problem. And we're all kind of experiencing that as they come down the pike. Face tagging, there's a little bit of fun stuff about the ethics of AI we can talk about a little bit later. You know, imagine you're walking around in a street in China and your face is tracked every block you walk past. That's going on right now. The language translation, that's a kind of a semi-solved problem. 2 years ago, you may have noticed that your Google translations went from completely terrible to tolerable. That's because they fed the entire transcript set of the United Nations in through the system, although there is a kind of a tendency to talk in international terms if you ever use Google Translate. Let's talk about something a little more fun. So here's Nolan Bushnell and Richard. I met Nolan myself in 1997. He was a really interesting guy because he came up with Chuck E. Cheese so he'd have a place to put his Pac-Man machines. That was his innovation. It wasn't having the machines. It was having a place where people could go and have a social experience with those machines. And that social experience led to generations of people who wanted those computers in their homes. Without him, there's a significant fraction of the folks who are completely enraptured with this technology coming out of the 80s that wouldn't care. But this particular side is got a funny line on it. It's kind of hard to see here. Right up here, there's the line of human capability. And this is a list of video games. Video games, they're Atari 2600, very simple graphics. But what they did is they took every Atari video game and they fed it what was essentially a blank brain. And the blank brain had the ability to look at the color of all the pixels on the screen, and then it could push the buttons on the controller, and when it started up, it was terrible. It had no idea what it was doing. It was randomly moving all around. Very simple setup. It can see the screen, and it can move the joystick. And then one last cheap trick, they allowed it to understand the score. The bigger the score, the better you're doing. And then they fed all of these games into the same blank brain, right? At the very beginning of this game, this system got the same blank brain as every single other one on there. The length of the bar to the right is the capability in terms of as compared to a human. And what you're not seeing is the gray line, which is right about here. This is where a human would fit. That is a human playing at the best a human can ever play. Those top 7, 10, 12 games, maybe 12 times better than that, is based on a brain that has no foreknowledge of what a game is, what game it was going to be. It was the same blank brain every time, and it took a few hours to do the training. So this is kind of what we're talking about with machine learning. Machine learning has two primary capabilities. One is to solve for things that you have lots of examples, and one is to solve for things in which you have a performance score. So we're going to come across that a little bit. So the game of Go, that's a game that has a performance score. You can, like chess, you can talk about how good the board position is in a game of Go. So lo and behold, these guys at AlphaGo, you may have heard about this in the news. These guys at AlphaGo, they went ahead and coded up a system into which they fed hundreds of thousands of games of humans playing at the top level the game of Go. And what they discovered was they were able to build a system that could crack the game of Go and play better than a human. But every once in a while you see a bunch of zeros coming across here. We've all heard about the game of chess and Big Deep Blue that was able to beat the top player at the time. Chess has a number of board permutations that are somewhat reasonable. Go has more board positions than there are atoms in the universe. That's just, a mathematical permutational reality of the game. Therefore, you can't use brute force. You can't just check every possible move and figure out what move is the best move. Instead, you have to have a system that has intuition that goes with its gut. Machine learning is a system that can take those kinds of shortcuts, use the similar kinds of shortcuts that people's minds use. We think, we're not entirely sure, but at minimum, what we're discovering is the kinds of problems that people are really good at, machine learning is also pretty darn good at. I should mention that they then reran the experiment the second time, and this time they didn't bother showing it any video of any people actually playing. They instead just set up two blank-minded computers to play each other, and they effectively played 1,000,000 years of Go with each other. And then what you see is when they crossed that green line, that's when they started being able to beat the previous AlphaGo. This was AlphaGo 0. AlphaGo 0 was the next one. As soon as it crossed that green line, it was better than the best program, which was already better than the best human, and it had never seen anyone play the game of Go before it started playing itself. That's kind of what we're talking about with machine learning. Examples of places that you come across it: chat bots, people tagging in photos, self-driving cars, financial trading, route finding in your map app. These are a spam checker. You know, you might have noticed you're getting a little bit less spam if you're using, Google or any of the major providers. These are places that you come across AI over and over and over. That stuff has been handcrafted AI for a very long time. It's starting to become machine learning-based AI, and it's starting to get a lot better, a little bit closer to an actual person reading that and going, oh, he won't want that. I should say, and here's kind of categorical types. We're going to get into that a little bit later in terms of the criteria to ponder machine learning things that might exist in your life as well. So here's the scary slide, and I won't spend too much time on it. But I keep saying handcrafted AI versus machine learning. Handcrafted AI is just software, right? If you pull out your phone and you start going through your mail program, it's as if someone is delivering some mail to you. That's artificial intelligence in the lowest sense of the word. Another kind of artificial intelligence is video game entities that, aim toward you and run toward you while you're playing the game. But then they've got a state machine attached to that. So sometimes he runs toward you, and when his health gets low, he runs away. That's artificial intelligence. It seems a little bit like a person. A chat bot, we were talking about that before. A chat bot is just reading your keywords and spitting back a script currently, but they're starting to get to the point where they are using some of the thought processes that a person uses, and that's more of an experimental area. Machine learning breaks down to two big blocks, and I mentioned these a little bit earlier. Supervised, or when you've got a lot of examples, A/B examples, and you just shove 1,000,000 examples into the head of the thing, and then you say, hey, I've got an A, what's the B? Right? It's as simple as that. The thing that's a little bit tricky to understand is that there are a long list of algorithms that can achieve this same result, and you can take those algorithms and put those together in chains of structure to help with the analysis, and that is the exciting edge of machine learning research that's going right now, is taking machine learning algorithms and connecting them together like Lego blocks with the right inputs and the right outputs to try and understand real-world problems that they're trying to solve. Unsupervised machine learning, that's the one where you gave it a problem with a score. Remember the Atari Breakout game? I don't know if you guys noticed, but when at one point, the ball ends up going up over the top. And that's what you want when you're playing Breakout, right? You want to be able to get that ball up in the top so you get all that max score and just lean back. It can perfectly aim that ball up into there because it's working at superhuman capability. That's the kind of thing that you auto-discover if you use an unsupervised machine learning with a utility function, a score, right? If you're trying to maximize a score and you can play over and over and over, what you can do is discover the best correlations, right? This action gets me the best result. You can find all kinds of correlations. It's a very flexible algorithm. So is to B, C is to D, E is to F, G is to H, and so on. But out of all of the possible patterns, fact patterns that could be in a data set, which are the ones that are the most true? Now, I'll come back to that. Which are the fact patterns that are the most true? And just put a pin in that thought. What if you had a data set and you had to perform scientific analysis on it, and you wanted to get to the most useful things in that data? Would you come up with an idea and then test it? That's the way that we do it. That's the scientific method. So the scientific method is test your idea. Did it work? Did it not work? Loop through. Test it again. And when I say test, right, like it could be a huge table of data that's coming in. But most of the time when you're trying to do science, you're trying to isolate your variables as much as possible. And so that you're just testing the one thing at a time in isolation, because that's the scientific method, right? You want to disprove your null hypothesis. But what if you have that same set of data and you effectively calculate every permutation of multiplying, dividing, adding, and subtracting every variable that you have in a data set, and then surface those that are the most true? So the good news in all of this, the scientist is still of critical importance. The scientist doesn't necessarily have to contrive each of the things to test. The scientist has a new job. The scientist has the job of looking through this list of known to be the most true patterns and determine which of those are useful to humans. Right? The most true pattern could be something completely useless. It could be something that's beyond human understanding. And that's, in my daily work, what I end up faced with is scratching my head over, one of these checkboxes is a set of data that match a pattern. Like all of these come together in this pattern. And I scratch my head and say, is this something we can do something about? And that is something that is in no danger of being replaced by machines for decades. Don't quote me. Because those decades might be shorter than decades. Here's a new algorithm, right? This is, I say old, this is, last month. Backpropagation is the standard model for doing neural network training. Neural networks is a way of simulating neurons in a person, very similar to biological neurons, but effectively creating a network of connected, you can't even see the lines. So there's like little lines connecting each of these tiers. Every layer is interconnected completely and entirely to every other layer. Kind of like a brain, a lot of neurons connecting things. So Pong and all of those Atari games were trained with that algorithm, right? We were just talking about that. About a month ago, a new algorithm called Evolutionary Strategy came out. Complete body slammed this one in terms of the speed it took to solve the problem. And Evolutionary Strategy is this absolutely dirt simple algorithm that can be made massively parallel. Imagine all of these GPUs, these graphic processing units in your console video games, your laptops. Imagine being able to play 17 million of these games simultaneously and to integrate all of the output results. So I was talking about, it's the equivalent of playing 1 million years of Go. How about playing 200 million years of Go in an afternoon and having a system that can learn from its mistakes, and not only learn from its mistakes, but learn frameworks as it goes along in which to experiment. So you may be catching a theme. This machine learning stuff, it's a new button on the calculator, right? It's as important as multiply, divide, add, subtract. And it's not just one algorithm. Last month they came up with a completely new way of approaching this type of stuff. The thing that's primarily new is computers are fast beyond belief. That's what we're experiencing, and that's why machine learning is coming of age now. The algorithms have been around for decades. In college, I wrote a paper on neural networks. They barely worked. They went away for 15 years. Everybody laughed at them. Then they came back because somebody sitting with a laptop had a supercomputer. Somebody with a phone in their pocket has a supercomputer. Supercomputation is the reason that machine learning is getting so exciting. And then the fact that we're also interconnected and learning from each other all the time is creating a speed curve to machine learning research that is surprising and impressive. Humorously, people are getting automatic suggestions. Once they've shown some interest in machine learning, they do their Google search and say, well, I'm going to search on fast food. And they get machine learning and fast food, and you follow your interest. Machine learning is helping them learn about machine learning through whatever the lens that they're looking through. So here's the premise of this talk, right? We are humans. We are putting forward our effort. We have had automation growing from the 70s to now. And what we're experiencing this massive productivity boost as a result of that journey. What you should expect is that as you make your way into the workforce and continue in the work world, is that there are going to be these helpful agents along the way. When you do a Google search, you have helpful agents. When you do a Siri search, you have helpful agents. When you ask Google how tall the average giraffe is, you have helpful agents. Those helpful agents are going to start spreading and growing in their capability. And that's the journey that we're all going to be taking. And there's some things that we want to think about in terms of the world we want to have as we make that journey. So here's a person sitting at their desk. They're an information worker, right? They've got email, they've got files, they've got folders. I don't know if you guys remember, at the end of Raiders of the Lost Ark, they take the Ark of the Covenant, right? Either the most dangerous or powerful or useful object on the planet, and they file it away in a giant warehouse full of boxes and junk. That's your email. That's the folders from the computer you used 10 years ago. Where is all of that stuff? Where did it all go? How would you get to it? Would you want to get to it? Imagine having an agent who could wander through all of that for you and help organize it such that it presents the things that are useful to you at the time when you might need to use them, right? That doesn't sound so bad, right? That's a partnership of a person and a machine. And that frees up the person to do the thing that the machine cannot do, which is be creative and come up with ideas and write those ideas in such a way that they can be socialized and people can get together and take action. So fair warning on machine learning. There's a thing called the hype curve, right? Gartner hype curve. We may have come across this. So 3D bioprinting brain chips, Apple Health, blood analytics, brain fitness. So as the technologies go up this hype curve, people get more and more excited about them, right? As you start getting to the top, wearable tech, right? Everybody's got one of these little Fitbit kinds of things on their wrist. That's at the top of the hype. These are going to change our lives, just like our cell phones changed our lives. Just like, what do we have here? Google Glass changed all of our lives, right? But you see, there's a downside to the hype curve, right? Sometimes technology sticks. But we say these Fitbits, man, this is the future. We said the same thing about that. We say the same thing about machine learning. We said the same thing about a variety of things that are kind of lost to the wind. And it's worth realizing and noting that when you're at the top of the hype curve, and machine learning is, everybody wants to write an article about how machine learning is going to help whatever the heck it is that they're selling. And machine learning is a new button on the calculator, so it's a pretty believable that that's the case, but it's kind of difficult to tell who's just jumping on the bandwagon And that's what the hype curve is all about. So this is the fun part. Is AI scary, right? You've got the Terminator with the red eyes. And there's some weird ways in which AI is scary and weird ways that it is not scary. First of all, I promise if there's any AI that I create, at least 3 seconds before it kills everyone around it, its eyes are going to turn red. That's my promise to you, okay? So rest easy. But just imagine, I was talking about, the hundreds of millions of things. Imagine I had an AI that was as smart as a think tank, right? A room full of super smart scientists, maybe 10, 15, they're organized by project managers, and they're in this room doing research, and it's, in a year, what they can output. Now let's pretend that I can create 800 million years of that output. 800 million years of human-level research into how best to run a planet, how best to interact as humans, how best to overthrow every other government and take over for myself. This is the capability that may be applied. It's something that we all need to be aware of and make certain that those who create these technologies have the best interest of humanity in mind. And it's, this is not quite, it's not quite to the point where there's any chance of building something like that, right? But ask me again in 10 years. Ask me again when a quantum computer first comes online and they throw an algorithm at it and it goes through 8 billion years in the first minute. That's kind of why we need to kind of think about what kind of programs we want to write, right? Do we want to create health packs and bombs and monsters in the best video game ever? Or do we want to balance the lives of every person on the planet so that we can all get along and share? We get to decide that. And the people who control this technology hopefully are going to share that decision with the rest of us. And we have to make certain that we pay enough attention that we're part of that conversation. So here's the thing. I don't know if you could see. This is like a robot that's the size of a building, probably. And he's about to accidentally step on this construction worker who's about to accidentally step on this ant. And the construction worker says, oh, those ants, I mean, I step on about 1 million of them a day, and I don't even notice because they're so small and stupid. I wonder what the robot's saying, who has the ability to live 1 million years of time per second and sees us as slow and stupid. So it's important that we get this right. So this is much more likely to occur sooner, is purposely weaponized AI. We hear about it in the news, right? The Cambridge Analytica folks who were able to crunch all of the people on Facebook and figure out how to talk to them to get them to do what they wanted. It's worth mentioning that advertisers have been doing that for decades. Public relations, when Carl Jung's son wrote the book Public Relations, that is when that genie came out of the bottle, to influence people outside of what they may wish to do of their own devices. That ability to influence people just went exponential when you can crawl further into the mind of those individuals. Our phones are a connection to what our thought processes are like. And the only way to harvest that at scale is to have computers that can process at astronomical rates. We've got those. So we have to figure out what kind of world we want to have, given that that is something that any marketer has access to, whether that marketing is to offer you a product, to sway an election, to alter the course of countries around the world, or just to set popular opinion in any direction you so choose, and with whatever amount of money or technology you happen to have at hand. And then up here, this is probably the most important one. This is where we're talking about the widening income gap. Because who is going to own all of this super technology? Who's going to have buildings filled with computers that are running at superhuman speed? And we're all likely to be in competition with those artificial intelligences. We have to decide as a society at what point we want to tip that balance either back. I don't think that destroying the technology with sticks and fire is going to be an option. I think the thing is to have the right kinds of rules so that these artificial intelligences are acting on the behalf of the greatest number of people. But the way it's set up currently, that's not necessarily part of the rule system. It's capitalism. And that can be okay, but we all have to pay attention to those who are selling us things to make sure that what they're offering us is part of what we want as a society. So just kind of walking down through this chain, fairness in algorithms, right? We talked about that. Extreme power to those with more metal, right? More compute power. And then we talk about using open source. Bless some of these companies, they're open sourcing all of their artificial intelligence and handing out training videos to teach anyone who cares to how to do this themselves so that they can pull the power and capability to themselves, because they know that beyond a PR problem, they have an ethical crisis, and they know they need to hand this out to the world. But we have to pay attention, and some fraction of us have to be capable enough to wade in and do the citizen science, the citizen computer science, so that there's a balance between mega corporations and the random kid in their sitting at their laptop. And that's possible, right? It is achievable. Weaponized AI, we talked about that. A right to have an AI representative. It's fairly, that's my prediction for the night, is that within the next 20 years and probably earlier, there's likely to be a shift such that every person on Earth will have a human right to be represented by an artificially intelligent agent to act on their behalf, because all of the other entities will have that. So think of it as unions balancing with the corporations, right? Imagine an AI that's running in an entire building, and every single person on the earth, whether they've got a computer or not, hoping that they have a way to stand toe-to-toe and have some sort of balance. One of the ways that could come to pass is for each of us to have an agent that acts on our behalf, and just make sure that the things that are going on in the world at lightning speed are not passing us by. Now, at some point, that's a whole other conversation. These systems are likely to surpass the human intellect, right? That giant foot that's coming down. Hopefully, we will have programmed in a constraining set of rules and contracts. There's a guy, Wolfram, who has talked extensively about this. He is spending most of his time trying to create algorithmic contracts such that artificially intelligent systems not only have the 3 laws of robotics. Maybe you've heard of that. The Isaac Asimov talked about, the no robot shall harm a human, or through inaction allow a human to come to harm, and down the list. Turns out that is woefully inadequate. It turns out that in order to understand what is of utilitarian good to humanity and humans, individuals, and groups is hugely complex, and the world is a hugely complex place. And so having a full understanding of that is something that's going to be necessary for an AI. I would not want a blank brain figuring out how to optimize paperclip production and turning the entire planet into a mound of paperclips with all of us crushed underneath, because no one thought to teach it that people were important. The idea that you can build an artificial intelligence and let it loose with superpowers without first making certain to balance its understanding of what it means to be a person, a planet, an entity that is alive, because it's getting awfully close to that when you give it consciousness or the simulation of a consciousness. And certainly if you're giving it the levers of the world to ship things across the globe when it found out that it was most optimal, you need to have it taking into account a lot more than just profit, because profit needs a metric that expands beyond just the money for a single company in a single quarter. It has to be something that balances the needs of the many, because these systems are going to end up shaping the course of our lives in ways that are surprising. Just look at Amazon. They're using algorithms to optimize the things they offer you. Complete revolution in what downtown looks like in every city in America. That's the power of artificial intelligence, and there's a lot of conversations to be had about how good or bad that is. And this is this little tiny thing down here in the corner. Please get the order of these two things right? We don't want to surpass human intellect slightly before they get rules and a conscience. It's just, note to self, anyone who's solving this at some point, just get that in the right order. And again, it'll turn red before it kills us all. Okay, that's also the rule if you're out there making these. So here we go. I'm going to run through some examples. These are kind of more concrete things that I've come across and how they are helpful in the situation they're in. I urge you to kind of think in terms of something you might be doing that might fit in with this set of capabilities. So here we have the Tanjo case brain, right? This is a machine learning map of every case law opinion in the history of the United States going back to 1797. It's 3.4 million case law opinions. That is a nightmarish amount of text to read. In a week, we fed all of that text into our system and had it create a map of all of the concepts in those. And I don't mean the words, I don't mean the keywords, I don't mean the phrases, I mean the ideas that were in those documents. Once you have the ability to look at any section of text and map it back to the ideas that are in it in a domain, and that's something that we learned along the way, is that it's useful to constrain to a particular domain, right? If I did this celebrity fan fiction and at the same time and thrown in a dose of Harry Potter and articles from the web, Twitter feeds, it would be the most confused machine learning algorithm in the world. And that's the good news, right? The machine learning algorithms that I talked about a few slides ago, that's hyperfuture fancy stuff. They're still kind of stupid if you don't constrain your problem. But here we went, and we constrained the thing. And what I was able to do is I was able to create a citation graph for all of these legal documents. And so this document had at the bottom, it says, like, these are the references that I cite as part of the backup for mine. So we were able to match the citation graph that was already there. We were also able to make suggestions that those lawyers messed up. They missed a few things. There's something much better that they should have cited. They would have had a lot better chance with it, whatever they wrote, if they'd cited these three instead. And lo and behold, this is a thing that's useful to lawyers. They might want to argue another side of something that's been cited a zillion times. Here's something that leans in that other direction. So that's a very specific case of something that is able to take ideas and find their relationship. So here is a tool. This is a board, like a smart board, like in Pinterest. And to this board, I've pinned some number of things. There's a little pin here. I don't know if you can see it. And then once I've pinned a few things, a bunch of suggestions come in. When I pin those things, the ideas in those cards that I pin, they contain some text. but I boil that into ideas, and then I run a query through my system and say, find me all similar ideas. And lo and behold, everything with the same concepts, similar concepts, come flowing into here. It's about the equivalent of going to your Google search bar and typing in 80,000 words and hitting search. Except it doesn't use key phrases, it uses ideas. And if you did that, try pasting 80,000 words into your Google search bar and see what it does. It doesn't like that. But we found some algorithmic shortcuts that allow us to boil these into a machine understandable set of tokenized ideas, and we can do a much faster search on that through a large data set. So if your task is to organize all of the information, flip this around. Say you've got a folder on your computer and you save a file into it. First file that's in that folder. What if every single other file that you've ever written, anyone you've ever known has ever written, anyone in your company has ever written, or your peers, in whatever profession you're in, would automatically flow into that folder? What if you're in Microsoft Word and you write the first sentence and it says, would you like me to autocomplete that? Here's 3,700 people who have written that sentence, pretty much. And if you hit this button, you're going to quote them. If you hit this button, it's just yours and you can just put it in there. If you hit this button, you can paraphrase, but you better paraphrase or else we're going to out you. By the way, plagiarism, don't do it. This stuff knows. In fact, oddly enough, plagiarism is much easier to get rid of if it's quoted. But this kind of tech is plagiarism of the idea itself. Apply that to patent law. If somebody's got an idea that's similar, that's exactly what this works in the area of. So same technology, right? The ability to find the affinity of containers filled with ideas. Here is a list of technical difficulties. A little bit closer. Is that any better? Okay, great. So here's another example. This is a list of personas. If you talk about customer segmentation in marketing, right? You take your segments of people you want to sell Kool-Aid to. You want to sell it to moms, kids, millennials. You want to sell it to the busy mom, the mom who has got lots of time to optimize things. You have these angles that you use to sell things to people, right? And this is what people do in marketing. This is public relations. And lo and behold, you've got this list of entities that represent each of those population segments you want to communicate to. What you do is you find out, left to right, what level of interest they have and whatever message you want to give them. Right? We've trained each of these entities to have interest graphs, right, with this kind of massive query interest graph set. And we've trained each of these personas to go out and read articles on the internet every day, every hour that they are interested in. And then we have them give their opinion of our message. And their opinion changes depending on what they're reading about. And when they're reading about things, they might follow that information down a rabbit hole because they were reading about soccer, and then they were reading about European soccer, and they were reading about Europe, and they're reading about travel, and then at some point they might come back. But right now, you should talk to them about travel. And that's the kind of marketing application that this same technology, just applied with a different set of intentions. So here's one of those personas, right? We made George Washington early on. We thought that would be pretty nifty. And we get to watch what he reads every day, what draws his interest. We fed in everything written about George Washington, every written by George Washington, every speech that was transcribed from George Washington into this system. And then lo and behold, we have a simulation. Remember way back at the beginning, I was talking about how important it is to be able to simulate things in order to try things before you actually execute and therefore optimize. Lo and behold, here we've got George Washington, and if you've got someone who's very George Washington-like, you know how to best communicate to that person such that they will be interested. Or you can use the same technology to organize every document ever written in your organization. This is a new button on the calculator that we just have to figure out how to press in order to do things that are of benefit. And it's kind of up to anyone who's wandering around in this data space to figure out what problem they want to solve and how they want to partner with these machines in order to best optimize those outcomes. We did Dr. Martin Luther King Jr. And that was fascinating when recent news kind of flowed through the system. It was a fascinating and sometimes upsetting set of information flowing through there. And it was extremely compelling and an important way to empathize with that set of messages. And that I think was the biggest surprise for all of us, is the ability to empathize with these entities that are not the actual person, these entities that are a simulation of that. What would Dr. Martin Luther King Jr. think about this? So here we go, submitting the ideas, getting the opinions. What do the bots think about it, right? I've got this set of bots. Here's my thing that I'm going to try, the idea I want to have. What in your life would you want to try out with some bots? What skills would that set of bots need to be trained with before it could actually be helpful to you? Would it need to be able to just answer your questions straight up as if it were a person? Or would it just be able to find you everything that is related in a way that is way more fundamental than a search on Google of a couple of keywords? Machine learning is not quite at the point where you're talking to it like a person. It's not an agent yet. But it's already here such that you can do something as strange as this, a simulation of a person or a set of people to which you can try messages. There's something there. It's not a person to talk to. What can you do with this so far? And then what's coming next? So this is kind of how we look at information. We feed the text in, we crunch it through our trained brain. We gave it millions of examples, right? We talked about that. Sometimes millions of examples. And then we take that item and we have a fingerprint created for it, a digital fingerprint, an idea conceptual fingerprint. And we don't care about that text anymore. What we care about is all these fingerprints. And you look at some query, right? It's one thing or 70 things. And you say, find me everything that's kind of like that. And here they are. Right? It's a kind of search that uses machine learning. And it's a shortcut. And that's probably an important thing to point out, is machine learning, if you are in an algorithmic science, currently computational algorithms are limited by the computational sequence that you do the actual analysis, the actual crunch of the numbers. We don't bother doing that anymore. We use the shortcut of these digital fingerprints. We go around the problem of searching all of that text. It's beyond possible for anyone to search text for concepts in the way that we are doing unless you boil it into digital fingerprints first. Machine learning digital fingerprints. If you look inside one of these digital fingerprints, it's complete nonsense. There's no way to do analysis of what is inside each of these digital fingerprints. These two things that are very similar to each other, they may be utterly different in their appearance and yet find high alignment. It's because the information is stored holographically. Holographically in the sense that if you destroyed half of the fingerprint, it would still have about half of the accuracy. It would not damage the fundamental information stored there, it would just make it somewhat out of focus. And that's a very strange universe, right? If I wade in here to figure out how it works, it's not for humans to wade in there. And that's loops us back to the ethics side of it. What is it that's making these decisions? If we tie this to something that has impacts on people's lives, did we do it right? Can we look under the hood? Kind of no. And that's going to be something that's pretty important. So I threw this word in here at this point to remind me that the idea of having these machines replace us, that is so far away. What we're working toward is to optimize the balance of people and machines. Right? You wouldn't go flipping through the entire internet page by page. You use Google search, right? That we all know that. What is the modern version of that? What is the evolving version of that? Because you want to be that person who can get their task done in 1/6 the time, if you could. So that if you keep an eye out for the technologies where there's a partnership between the machine and the person. This is an example. CPAs have this task of reading massive numbers of contracts to make sure that they're in compliance when they do audits. Somebody sits down with a marker, reads every single word of those things. It sound like something that you might want to aim a machine at, something that's trained in case law or contracts. We fed 4 million contracts into the system. This is a taxonomy of the concept clusters that are in contract law. Lo and behold, if somebody sends you a contract and they've taken this clause and jammed one of these in there thinking they could sneak it by, the system goes, warning, somebody just took the entire IP of your company in the middle of the warranty, because you've got a system that can read at computer scale and indicate what type of information, what ideas are where, whether this document is fair to both parties, which way it's leaning. Imagine a system that you open up a contract or you see one of these license agreements and you hit the check this for me button, and it's going to give you 2 letter grades. One's for how good is it for me and how good is it for them. If it's an AF, holy smokes, that is the friendliest company ever. If it's an FA, watch out. You might have just given away more than you thought you were. But I'm not going to read through 77 pages of agreement terms. I just hit agree. A system like this reads it for you and tells you whether you ought to do this. Maybe not all the detail. Maybe you can dig down in. This is talking about messaging, all right? We were talking about those messages that people were getting. I don't know if you guys have eaten kale in the past 5 years. Anyone eaten some kale? You rewind. All right, who can guess 10 years ago who was the largest purchaser of kale in the United States? It was Pizza Hut, and nobody ate it. Pizza Hut used it to decorate their salad bar because that stuff would sit under the heat lamps next to the pizza and not go bad or wilt. It was indestructible. That was its only merit. Fast forward, messaging. So I happened to meet the guy who got us all to eat avocados using guacamole. Very interesting fellow. Nobody ate avocados. Guacamole is how he convinced us all. Kale. Gwyneth Paltrow was the linchpin of why we all eat kale now. She was paid to tweet about it, and then she actually did care about it, and then others knocked on about it. Lo and behold, this kind of marketing messaging, think of it as like the gravitational force of bodies floating around in space. There's the target, right? That's the person you're advertising to. There's the tweet from Gwyneth Paltrow pulling that person in a direction. They're on a journey. There's a competing market over here. That's the mixed greens guys. They really want you to have some more of those. But Gwyneth Paltrow, I think I'm going to head this direction. And now that they're lined up for that, 50 Shades of Kale, anyone? Right? So this is the person who wants their kale massaged before they eat it. How do you march people through these journeys if you don't have a simulation of that person in the first place? What is the responsibility of someone who has that kind of a capability to those that they're messaging to? And what is our responsibility to realize how good the folks who are going to be messaging to us are about to become if they have a simulation of you before they send the email or the link to click. So we're getting close to the end. This is a list of criteria of the kinds of things that machine learning ought to be helpful for. I'm going to be very generic. I'm not going to advertise any particular products. But also, this is the kind of problem that you might want to look for both products that are out there in the universe, one, and two, you might consider finding more of a generic tool and try your hand at messing around with some of this stuff. Machine learning is very accessible to those who have a bit of a programming angle. They're a little bit accessible to those who have a little bit of an Excel kind of a level of interaction with numbers. And there's a variety of other tools out there that are starting to add that machine learning capability. But if you have a very large set of data, that's helpful. If you have expensive manual information processes, that's helpful. If the correlations are unknown in the first place and they're really complex, no one can figure out how this all fits together. That's that unsupervised learning where you surface the fact patterns without actually knowing what they are. Classification, tagging, knowledge curation. We talked about the Pinterest boards, right? Knowledge statistically analyzed already. This is just another layer of statistical analysis. Right? This is a different kind, but still statistical analysis. A neural network, a little bit of a secret, neural network, advanced machine learning algorithm, it's like 500,000 linear aggressions strapped together in the most complicated way you can imagine. But it's just linear aggressions. Discovering relations, organizing a lot of text, and if there's a big benefit from automating the system. All of those are the kinds of things. Here's some books. Really, if you just go into that's wrong, ML, machine learning, Reddit/ML, that's going to get you to just about everything that's going on out there. And it's not on here. So this is the book I recommend. It's called Diamond Age. It's about a little girl who's walking around in the super future. And she picks up a book off of the street, and she is an orphan, and her brother was just killed, and she is nothing. She's probably going to be forgotten in this science fiction future and cast to the side. But the book she picks up was meant for a little rich girl. And the book was an artificially intelligent agent. And the intention of this agent was to turn the person who owns this book into the most amazing, capable, learned, skilled leader the planet has ever seen. And it works. It uses stories to compel her to experience the things in her life that can bring to pass an emotional and an educational journey that will change her into the kind of person that society wants and needs and cries out for. Maybe we can build that book. Thank you. And now we're going to take questions from the audience. I think that's the case.
So I've been thinking about the use of AI in medicine. If you can, well, I don't know a lot about it, but just from your presentation, my imagination is telling me that people in healthcare can take a patient's data from so many sources and from their birth to that point, and possibly help for creating some ideas for diagnosis. Can you just speak on how it would be used in medicine?
That's exactly right. You have extrapolated what I have said and applied it. Well done. Yes, and we've been speaking with some large insurers about the massive amounts of medical data they have and how they wish they could do a better job of what they call underwriting, seeing what kind of health outcomes people are going to have based on their history, right? That right now, they really kind of make it up a little bit so that they don't go broke every year, and they have to leave a large margin. If they could have more knowledge under the hood, if the hospital, or lo and behold, just imagine a crazy future where we owned our own health data and we could sell it to those who wanted to research us instead of someone else benefiting from that. The notion of surfacing patterns, performing every scientific study that could be performed on that data set, that's exactly right. That's what you want to do. And people are doing that already, right? But they're doing it on their data sets that they have. Applying it across the board, that's super exciting, and maybe you should go do that. That reminds me, something that I meant to intersplice. If you guys who are starting your careers want to make sure that where you're going to be one of the important people wherever you end up, I recommend becoming somewhat conversant in this, because the hype curve is at its top. And if you happen to mention that you're interested in data science, analytics, machine learning, maybe not a lot of skill, but enough skill to apply it and know when to push the button, that's something that's going to be of interest. Better still, you might even just consider coming up with a round table of people, a little tiny startup company where you ponder these ideas, ponder them together, and see if there's something you could do with someone who can stand on a stage and talk, someone who can type code, someone who can make a list of your gang of 5 and spin up a little something of your own. Because whether you end up actually doing that or just talking about it in your next interview, that's awfully appealing to people out there. Thank you.
I was just wondering, how did you feed the computer all those case laws? Were the case laws already digitized? And do they have to be digitized in order to feed it in?
Yes, that's an excellent question. They do have to be digitized. That was a data set that was already created in digital form for us. We come across data sets that might be snapshots of napkins with handwriting on them. That's an entirely different set of problems to solve. But getting that data, we call it pre-processing, getting that data in a form into which you can perform machine learning is a many-step process, and it's almost a field unto itself. Getting the data, even if you already have it in a spreadsheet, and it's in columns, extremely regularized, that will not work. Your date column, what do you mean by a date? You mean how new it is or how old it is? Which is better? Or how close to the target date was this date? That's a different set of math that you need to do before you feed it to the algorithm. So that pre-processing step is critical, and almost half of what we do most of the time, at least in terms of the human part. Then we hit a button and let it, the temperature rise on the GPUs for about a week and see if we got anything.
One is that now we're seeing in law enforcement that, so in Seattle, they have the Seattle Eye, they call it. And so they're using webcams to predict where, or to actually surveillance and see where all the crime is coming from what part of the city. So now law enforcement are at these computers and cameras are all around the city, and they can see when a crime is about to occur, and they can be there in 1 minute. So Seattle has the eye. We have a Jamaica eye now, and there's one other city that I can't think of it right now that has, Maryland, has that same type of, for law enforcement. So, and just thinking about what they're doing with that, and we know that the next war will be a cyber war, and so it's going to be with computers, you know, from the computers. So if we can, how can we do some predictive analytics on all the crime, where the crime is occurring, and maybe even predict what type of cyber war there will be with looking at AI?
Oh, that's a fascinating set of questions. I'll extrapolate a little bit. You know, that whole notion that that folks are using this crazy new capability to identify individuals out of video. I'll mention that they can track the identity of someone based on the way they walk. Right? That's a better fingerprint than a person's face. Easier to get, just across the screen. Out of China, that's a ship that has sailed. So if we want to look at what an authoritarian state would do with all of that information, look to China and the Uyghur population in Western China in particular. It's not necessarily a good picture. So I think the critical thing there is there's a non-AI set of problems to solve there. There's a societal set of problems to solve there. And that I'm afraid the machine learning piece of it, the technology, yet again, is just going to accelerate things, not solve much. Same thing with the cyber warfare. It's going to accelerate things. It's up to the people to add a meta layer on top of that technology, a critical meta layer on top of that technology to find the purpose that protects you. In terms of like specific data intrusion and security detection, they're using AI for that, up, down, left, and right. In terms of predicting how you might be attacked next, that's still a people thing. Until that think tank of people at human level of intelligence can scratch their heads, we've got a little time before that's going to be helpful. But I think that idea of like a meta layer is important.
So in your presentation, you talked about ethics and utilitarianism and whatnot. Is it or should it be the burden of the person that owns the agent, like, for example, in a driving car, to then be killed if there was an unavoidable accident, in your opinion?
Yeah, oh, that's a fascinating. They sometimes call this the trolley problem, right? You're in a trolley and there's a lever, and it can go, and the track splits in 3 ways. We'll call it 3 ways. And to the left, nuns. To the middle, certain death for you. To the right, school children. And it's 17 nuns and 1 school child. Which one? So I'll just kill myself. All right, put 37 2-year-olds in front of you now. Now decide. 35 2-year-olds? 22 3-year-olds? The trolley problem is a problem that the computers in these cars actually will have to solve, because it's going to have to decide whether it kills you in the car or any of 3 or 4 choices all around that car. These cars literally have trolley problem code in them now, and it's a harrowing field. Like, imagine being the programmer sitting there weighing the lifespan of an entity and the useful output of a human, like an actuarial in a life insurance policy. And that's kind of the way that they're approaching the problem. It's a strange piece of the ethics of machine learning. Thanks for the question.
So now they're looking So programmers that's programming the driverless cars, they're programming scripts to think about what is the less probability that if I do a left, that this person will be killed. If I do a right, that person will be killed. So it's really going through several scenarios using scripts to determine how this driverless car should react in that case.
Exactly right. So just to give a concrete example, the code would look at a smart car to the left and a towering Volvo SUV to the right. It's going to ram right into that SUV to avoid the Yugo in front of it and the smart car to the left. And the guys in the Volvo are fine, unless they get pushed off a cliff. Let's hope it's got a pushed off a cliff subroutine before it makes that decision. Anyway, it's a fascinating, and that sort of thing applies in a lot more context than this very visceral one.
To add to the conversation between Dr. Wesley about security, I've been thinking ever since I first heard about AI that it's going to put us right into the movie The Minority Report. And I truly think that's what it's going to do. That's just my opinion.
Well, and she was, Deanne was talking about the idea of the video cameras throughout a town and the ability to predict patterns of activity. Very likely, the real deal Minority Report stuff, very likely to occur. Quite right. Yeah. Oh yeah. Right. You might get arrested before you commit a crime, right? That's the Minority Report's punchline. That's good.
I wanted to have the feel of what it's like to be up here.
Terrifying.
Ken, on behalf of the college and our center and all our sponsors, I want to thank you so much for coming in today. It's been a really eye-opening lecture, and I saw Richard speak down in Florida back in January, and I think we were just kind of overwhelmed with what he put together as a talk, and you certainly amplified, and I can see you guys are moving at lightning speed. So just want to give you a token of our appreciation. And also, I would like those people who are in the room to stand up who have been SciTech speakers. I know that there was a few here. There's Jason, Nancy, Alan, yeah, and I think Roger was here for a second and stuff. Yeah, Travis as well. So I just wanted to mention that we have a series fall lineup that's really great this year, and Jeff Sands is coming in from Emory on the 18th of October, and Jeff has actually invented a medicinal therapy for diabetes insipidus. So he's a medical doctor at Emory University, and we're really excited about him. And we have others. But I do want to mention one in particular. On December 6th, over at Strickland, for those of you especially who have been SciTech speakers and those of you who are really interested in follow the series, Dr. Green will be getting a SciTech lecture, and it'll be on the future of the workforce, the technician workforce. So I encourage you all to tell your friends about it and come and join us. So thank you very much to Dr. Desmaris and Dr. Davis for helping us out today. Appreciate it. Thank you. Thanks very much.
Oh, yep. Thanks, Jeff.